A single loop of wire with a diameter of 0.780 meters starts at an angle. Okay, so concept zero, right? Our radius here is 0.390 meters. Is that true? Let's just double check that. 0.78 divided by 2. By golly, it is. All right. And then it starts like this. It's like at an angle. So if we saw it from the side, it would be like, and here's the table, right? And then at the end there, it's like this. Okay? So 78 degrees. Okay. And then there's a voltage making a current go clockwise. Okay, so the current in response to this goes clockwise. Okay, so let's think this through. Okay, the response to this is to create flux into the page. So I think what that means is that we have a magnetic field that's out of the page. Let's just, sometimes I have to go backwards, okay? So I think that there's dots. These dots are a magnetic field that's out of this page, right? And we gained flux out of the page, and the response to that is to create flux into the page. So into the page is the direction. So out of the page is the magnetic field, right? Okay. So we got that right. We got the direction right. And now let's figure out what the magnetic field is, okay? Now what's changing here is it's NBA cos theta, right? And what's changing here is the angle. So it's cos theta final minus cos theta initial, right? And that's over time, okay? And that's going to be our EMF. So we know that, so then we're looking for the B, right? And the B is going to be EMF times time. Let's see, B is equal to EMF times time over NA cos theta minus cos theta. Right? Okay, I think, right? Okay. So let's go, let's take our EMF is 32 volts, right? And the time is 0.016. Okay, and N is 1, a single loop, right? Our area is pi times 0.39 squared. Okay, and then let's think about this angle here, because really the area is in this direction. Okay, it's really perpendicular to that surface. So I think it works, right? Because if the magnetic field is like this angle's the same as this angle. Okay, so it's cos, I'll just say cos 0. 0 minus cos 78. Okay, cos 0 minus, oh my gosh. Okay, so I'm going to do this on the calculator with a fraction. I'm going to go alpha F1, enter 32 times 0.016, and then in the denominator 1 times, don't forget the 1 times pi, times 0.39 squared times cos 0 minus cos 78. Okay, I hope that I'm in degrees. Am I in degrees? I feel like I am. 1.3527 Teslas. So 1.35. Okay, and then the question is, which way is it, right? We gained the result of gaining this flux, that is, it's either perpendicular, it's perpendicular to the page, right? And the response to gaining this flux, that is, we have very little area that the flux is, that the field's going through. Now we have more area. Is to make current go clockwise, right? Then that must be, if we gained it, we opposed it, right? So the flux, we created flux into the page as a response to this. So the flux must be out of the page. Okay. So Tesla's out of the page. TP, out of the page, or dot. Woohoo! OODA. All right.